Hello everyone, this is Mahgoub. Today I'm going to explain about my LAB2, doing it individually. I'm going to explain the six codes on my own. First of all, this is question one. It includes two variables. The data bar1 is a word one decimal. Bar2 is also a word 9 decimal. So the first procedure will move the value of bar1 to the AX, which is 1. AX is holding 1 decimal, which is 1 also in decimal. And we'll move bar2 to the register BX, which is 9. So BX is holding the value of 9. Then it's exchange the values of the two registers. PX will hold the value of AX and AX will hold the value of PX. And then we'll move the value of the register AX to the bar1. And we'll move the value of register PX to the bar2. So basically this code will just reverse the values of bar1 and bar2 through the registers in between. So let's start debugging to see how good. So yes, EEX have the value of bar2, which is 9, and EPX have the value of bar1, which is 1. The rest registers are like this. Let's go. Let's go now for the question 2. So here the code for the question 2. It also have 4 variables. It is R-val, which is D word uninitialized, X-val, D word 26 in decimal, Y-val, D word 30 in decimal, Z-val is 40 in decimal, D word also. So the main procedure will, first of all, will move the value of X-val to the EEX, which is X-val 26 in decimal, which is 1H in hexadecimal, will be moved to register EX. So now EX have a value of 001A. If you negate this value, it will be 26 minus negative 26, which is 6F E6 decimal. Then to move the value of Y value, which is 30, to the register EPX, which is 1E. And then it will subtract the value of Z value, which is 40, from the register EPX. It subtract 40 from 30, then it's negative 10 in decimal, which is equivalent to this value in hexadecimal. Then it will add EPX to EEX, and then it will increment the value of register EEX by 1, from negative 63 to negative 30, from negative 36 to negative 35, and lastly it will move the value of EX to the R value, which is negative 35. It will be held in variable R value. So let's step over. So yes, this is after the moving, this is after the negating, after moving Y value to EBX. We see that EBX is changed to 1E. This after adding EBX to EX. This after incrementing EX by 1, change to negative 35. This after moving the value of this EX to R value. Here you can see this value in watch actually after that. Yes, that's about question 1 or question 2. And that's about question 2. And here I'm going to explain about code 3. So basically code 3 also have the same values. Have the same variable, 4 variables. Bar 1, D was 5, bar 2, 10, D was, and bar 4 is initialized. In the main procedure, we have to move the value of bar 1 to the register EEX, and then we have to multiply the value of bar 2 by the register EEX, and save it to the register EEX, and then we have to decrement the register EEX by 1. So let's debug. Let's step over. Step over to see the changing. So here after we move the value of bar 1, which is 5, to the register EX, you can see that register EX has the value of 5. And after we multiplying bar 2, which is 10, by the register EX, which is 5, to be 50, which is equivalent to 32 in hexadecimal. And this after we add the value of bar 3 to the register EX, which is 20, we added to 50, will give us 70, which is 46 hexadecimal. The last thing we are going to define in this value of register EX, which was 70 to now become 69, which is equivalent to 46 hexadecimal. This is all about question 3. Okay, and here I'm going to talk about, I'm going to explain about question 4. Question 4 have 3 variables, bar 1, bar 2, bar 4. Bar 1 have 40 in decimal, bar 2 have 10 in decimal, and bar 4 is initialized. So we are going to perform 7 operations. First operation is we are going to move bar 1 to AX, which is 40. So register 1, register AX will have the 40, and then we are going to move the value of we're going to assign the value of 5 to register px, which is immediate value, and then we are going to multiply register px by register ax and store the value in register ax, and then we are going to move part 2, which is change the register px, then change the value, then we are going to subtract 3 from value from register px, then subtract 3 from 10, which is 7. Then we are going to divide px by ax, and then we are going to move the value of ax to the part 4. This step over should be more clearer. Step over. You can see the changes in the values of the registers. Here, after we move the value of R1, we can see that register ax has the value of 28 in hexadecimal, 40 in decimal, which is equivalent to 28 in decimal. And after we move the value, immediate value of 5 to register px, you can see that register epx has the value of 5 at the end. And after the discrete line 3, you multiply px by ax, you can see the changing in register ex, which is multiplied 5 by uh, multiplied 5 by 40 in decimal, which is 200 in decimal, which is equivalent to C8 decimal, which is the result of the multiplication. And then we are going to move our 2 to px. Our 2 is 10. Px now has new value, which is 10, equivalent to a hexadecimal. Subtract 3 from px, is 7. And then we are going to divide px by ax until the value is ax. So you can see the changing the register ex, which is 1c. We are going finally to move the value of ax to bar 4. And here bar 4 have the value of ax, which is 1c. You can see this from the watch. So I'm going to talk about question 5. Here is my code for register for question 5, which is I need to complete the code snippet. So first operation is keeping the value of register tx by moving 0 to register tx, and then we are going to move 1000 hexadecimal to register ax. So now register ax hold the value of 1000, and then we are going to move the value of 25 h to register cx. So register cx has the value of 25 h, and then we are going finally to multiply register cx by register ax, and then the value will be stored in dx. For the one register, after that we are going to see the changes in all registers. See here the changes in the registers. STCX hold the value of 25 and change, and register EAX have the value of 5000, which is multiplied by 5, and the value of EDX have been changed by after we store the result of the multiplication in the register 3BX. This is all about question 5. Now I'm going to explain about question 6. So and here I'm going to explain about question 6. So I'm completing this code which perform 4 operations, division. So first of all, to create the register dx by assigning it to 0. Second of all, to move the value of 803h to register ax. And then it will move the value of 10h, which is the immediate value, will be assigned to b lower. B lower is actually the divisor. We have been dividing b lower by ax. So we are going to divide b lower by ax. So let's see the debugging. So we can notice that after we debug, the value of register EBX again still 0, and the value of the register EEPX again lower or also assigned to 10, 10 which is 10H, the value of P lower, and here the value of this of EEX have been also same. Uh, just reversing the values since the lower will be before the higher will be before the lower. 0380, and uh, that's all about question 6. Thank you.